A third example. Find the area between y equals x cubed and y equals x. Well, okay, we start by finding out where do they overlap. When x cubed is x, what is that? X cubed minus x is 0. Factor out an x. X times x squared minus 1 equals 0. That can be factored even further. X plus 1 times x minus 1 is x squared minus 1. And so x is 0, negative 1, and 1. Ooh, what happens? Well, we have 3 different points where they overlap. Can we just use the largest of the two? Can we just say the integral from negative 1 to 1 of x cubed minus x dx, and hey, use those absolute values, ta-da. Well, maybe, let's see. X to the 4th over 4 minus x squared over 2 from negative 1 to 1. Absolute values. Usually you only put the absolute values at the end if you've got a negative, but yeah, they're legit. And we've got what? 1/4 minus a half minus 1/4 minus a half. In absolute values, 1/4 minus a half is negative a quarter. Negative a fourth minus negative a fourth, which is negative a fourth plus a fourth, which is 0. There's no area between these curves? If there's no area between them, you'd think that they are exactly the same. X cubed and x are exactly the same? Well, no, they're not. What happens is, this is sort of a zoomed in curve, y equals x cubed goes through these 3 points. Here's the line y equals x. And the y equals x cubed curves up like this for the sort of traditional y equals x cubed graph. And the problem is that it switched from negative 1 to 0. The y equals x cubed is on top. And from 0 to 1, the x is on top. So really what we need is we need to split it into 2 different integrals. From negative 1 to 0, it's x cubed minus x dx. And from 0 up to 1, it's x minus x cubed dx. And so we get x to the 4th over 4 minus x squared over 2 from negative 1 to 0, and we also get x squared over 2 minus x to the 4th over 4 from 0 to 1. When we plug in 0, we get nothing. When we plug in negative 1, I get 1/4 minus a half. And over here, when I plug in 1, I get 1/2 minus a fourth. And when I plug in 0, I get 0. And so what we end up getting is, let's see, that's negative a quarter, negative 1/4 plus 1/4 is 1/2. And that is exactly the area of this plus this. And in fact, this 1/2, this 1/4 here, which was the integral right here, is exactly the area of 1 bit of this. Now, if you could somehow convince yourself and me that it was immediately clear that this and this had exactly the same area, and there are ways of doing that, then you could have said that the area was just 2 times the integral from negative 1 to 0 of x cubed minus x dx. If you're so sure that this area is exactly the same as this one, find one of them and double it. That is a possibility.